Hi, this is Randall Schwartz, host of Floss Weekly. This week, Gareth Greenaway joins me. We're going to get really geeky. We're going to talk about parsing with the MARPA parser. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Gareth Greenaway. Episode 321, recorded January 14th, 2015. MARPA. It's time for Floss Weekly, the show about free, libre, open source software. I'm your host, Randall Schwartz, Merlin@Stonehenge.com, bringing you each week or as often as I can the movers, the shakers, the big projects, the little projects you may be using every day and being totally unaware of it, projects you might want to go download right after the show and go play with. Today's probably going to be one of those. Let's bring on our co-host, Gareth Greenaway. Welcome back to the show.
Thanks, Randall. Thanks for having me. Glad to be back.
Yeah, and you're in the midst of things about scale. We'll talk a little bit about that at the end of the show, but I'm really glad you could take a little bit of time out and come join us today.
Yeah, thanks for having me.
And you're in your, I presume, your secret bunker in Thousand Oaks somewhere?
I am in my secret bunker. Yep, deep in Thousand Oaks. It's a cool day. I think it's in the high 60s at the moment, so we're right in the thick of winter.
You guys in SoCal. I'm actually back in Portland. I am sitting in my apartment that is about to be lit badly by the sun. Usually we're trying for overcast days here in Portland when I'm shooting the show, but today is a clear day, darn you. And so you might, if you're watching the video, you may start to see that light behind me start to move right across my face coming up real soon. So that's just the way it is. We'll deal with that. But today is a fascinating show. I've been wanting to find the right projects to use this project with. It's going to be a geeky show. I'm going to warn you right ahead of time here. First off, it's Perl. Yay, Perl. Second, it is about not end-user software, but about software that you use to write software. So it's sort of a backing up one step. It's a library. And the particular class of software you'd be writing with this thing is an area called parsers. These are things that are used to recognize, say, HTML or custom languages for things, or pick things out of a complex data structure to be able to, create other data with it, that sort of thing. The particular parser I'm about to speak about, or about to talk about with one of the experts from the project, is MARPA. And MARPA has been around for quite a long time, since 2007, 2008, somewhere back in there. And I first met Jeffrey Kegler, who was the originator and still head honcho for MARPA, because he wanted to help me with the information website about my criminal conviction. And so he set that up very well, and it was really great. And then I started talking about what else he's working on, and he's, of course, a Perl hacker. And so he said, I got this thing that I've implemented the early parser, EARLEY parser. And the fascinating thing about it is it can track ambiguous grammars and give you all possible parsers of something. And so like one common case of that would be, for example, if you have A plus B plus C, depending on whether you wanted the left-hand side to be the more dominant one or the right-hand side to be the more dominant one, if you don't specify, then they're both equally available grammars. And so here, Gareth's eyes are probably glazing over by now, but and probably about half our audience. But anyway, so what we have on today, we have Andrew mispronounced it, Andrew Rodland. He's going to come along and talk about MARPA, and Jeffrey said Andrew would be a better spokesperson for this, so that's probably a good reason for him to do that. Before we get started, Gareth, anything you want to try to contribute to that?
No, I think you summed it up fairly well. Actually, I'm good.
Before we bring Andrew on, actually, I wanted to just read from the MARPA page why I think it's interesting. MARPA is fast. It parses in linear time all of the grammar classes that recursive ascent parses, which is a very common parsing language. The grammar class that the Yak family parses, Yak and its cousin Bison, are used quite heavily in a lot of the typical products that are out there. In fact, all unambiguous grammars, as long as they are free of unmarked middle recursions. By the way, some of this is glazing my eyes over too. So if you in the audience we'll get good explanations, I hope, for most of this stuff. That all ambiguous grammars that are unions of a finite set of any of the above grammars. And it's powerful. It will parse anything that can be written in B and F. which is the common representation for grammars and stuff like that. So the 4 computer science people in my audience are probably now geeking out badly. They're like, wow, this sounds good. Yeah, well, this is the reason I wanted to get these guys on the show. So without further ado, let's go ahead and bring Andrew Rodland onto the show. Andrew, welcome.
Hi, Randall. Hi, Gareth.
And where are you speaking to us from?
Am I coming through?
Yes, you're
from
coming
New York City.
New York City, right. And it's probably, let's see, it's probably about 30 or 35 here. And Gareth just said it was about 60 where he was. And how warm or cold is it in New York City today?
It was about 15 when I left this morning. I think it's going to get up to around 30 today.
And anyway, you're not Canadian. This is U.S. temperatures, right?
That's right.
Because it sounds like it'd be Canadian temperatures for this time of year, but no, I guess Canada has invaded the U.S. Well, okay, so I hand waved a lot. Do you have a simpler way of getting into this, or is there no simple end to describing what MARPA is good for?
Well, for starters, I don't have the PhD either. I couldn't actually tell you what an unmarked middle recursion is. I kind of I trust Jeffrey on some of this stuff. Mm-hmm. Yeah, essentially, I'm sorry, go ahead.
I was just going to say, let's start then with what attracted you to MARPA in the beginning, and what have you been using it for?
So I've always had sort of a love-hate relationship with parsing. I'm very, very practical programmer, but I have a geeky side, and I followed some of the stuff in the past for parsing in Perl, especially some of Damien Conway's projects like Parse Rec Descent and Regex grammars and some things like that. Mm-hmm. And the thing that attracted me to them is that they're very easy to dive into. Anybody can go and have an idea of a language in mind and write a grammar and not need to know a lot of academic stuff and not need to do a lot of advanced work. You can just kind of dive in and write something practical. Mm-hmm.
Well, I know one of the things I used Parse Rec Descent for was I did a safe eval for DataDumper, because DataDumper mm-hmm. generates essentially Perl code, and the normal way to turn that back into a Perl data structure is you run eval on it. But the problem with eval, of course, is it's completely wide open. So I used Parse Rec Descent to drill down and do similar to what the Perl parser is doing when it's trying to do that kind of data structure, but I'm doing it in a very controlled way, and nothing that's not one of my legal steps will get past it and become the actual data. So that's one of a class of parsers that you might write. What other kinds of things have you written?
So the TAP, the Test Anything protocol, I'm sure you're very familiar with. Mm-hmm. And there was an effort.
Why don't you go ahead and describe that for our audience, though? Yeah.
It's a language for basically communicating the results of test suites to a test harness. So any kind of test-driven development, test programs that you want to write for your programs, if they output in this language called TAP, which is basically just a summary of the results of the tests, then you can have all kinds of tools, recognize whether your tests are passing or failing and do summaries of how your tests are doing.
So let's actually back up a little bit, so understand why people need parsers. We have multitudes of data out there, and everybody invents their own formats for what this data is going to come in as. I mean, XML mm-hmm. is sort of one format, HTML is a different format. You have comma-separated values that have the need for things that are being, quote, escaped and things like that, and like that. And so that's why you would reach for a parser, right? To be able to take that multitude of data and turn it into something.
Right. Anytime you have some sort of structured data and you need to get something out of that structure into the computer, basically you're doing parsing, whether you're parsing a programming language, whether you're parsing a format like JSON or XML or HTML, even binary file formats, we don't usually think of them as parsers, but something is going to go in there and say, these are the fields, this is how long they are, these are the types of things that are allowed to occur in this order, and all of that is a parsing job.
Well, there's always the old adage that, you think you want to parse something, so you reach for regular expressions, and now you have two problems. Does MARPA make it a third problem, or does it make it easier?
I think it makes things easier.
So what's your interaction with MARPA? How do it's obviously Perl. So are we building like a Perl data structure to give MARPA something to work for? I mean, describe the flow. Like, okay, I want to parse a comma separated value file, which has been done a million times. But how would I sort of interact with MARPA to say what CSV really looks like?
There's different layers where you can actually interact with MARPA, from the very low level, which is basically a wrapper for the C library, to a medium level where you can actually feed it a grammar as a Perl data structure. But the one that I would recommend most people get started off on is called the scanless form, where you can input a BNF grammar, the exact kind of thing that you would find in an RFC or a protocol description on the internet. And you can give that to MARPA with almost no modification at all, and then tell it, make me a grammar based on that, and give it some input, and it will give you a syntax tree for whatever input you gave it.
Yeah, so that's an interesting way to look at this. Like if you look at any of the RFCs, any of the internet RFCs, almost all of them, if there's some sort of text file over the wire format, will have some form of BNF. And that means, for example, it says that a mail message consists of mail header and a mail body. A mail header consists of any of these 25 kinds of lines. And if it's a subject line, it'll just have text by it. But if it's a from or a to, it has to have a particular structure. Is that the kind of thing I could hand directly to MARPA, or pretty close to directly to MARPA, and have it start building a parser from that?
Yes.
Okay, long question, short answer. All right. Sorry, I'm going to be too leading questions. I'm trying to give you questions that you can spend more time talking than I do.
Right.
So how would you? But describe the two different layers, because there's tokenization versus structure, right?
Mm-hmm. And that was always something that historically for me has given trouble. Creating a tokenizer is a daunting problem, especially for somebody without a serious CS background. It's how do I look at my input and identify right off the bat what kind of thing is this word that I'm looking at without the use of context. And it's a really tricky problem. And the thing about parsers like Recdescent is that they don't make you do tokenization. They just take the input as it comes, and whatever rule that they're parsing, it has a regular expression or whatever for the next thing that it expects. And so you never have to break it down, and you don't have to feed it pre-digested list of tokens.
And this is probably especially an interesting problem, like for something like Perl, where the token state depends a little bit on the current state of the parse. Is that kind of a parser easy to write in MARPA?
It's easier, yes. Perl in particular does some really very interesting, would be the kind thing to call it, but it does it does some serious tricks where it actually it sort of modifies its tokenizer as it parses things to be, and it pretends that it saw things that it didn't in order to actually come up with a parse that makes sense, because Perl has a very, very difficult, very ambiguous grammar.
Well, the grammar is not particularly ambiguous. It's just that it's very stateful. I remember reading somebody, I forget who did the quote, but parsing a Perl program is done with a Lexer, a scanner, smoke, and mirrors. because the biggest problem for people who aren't familiar with the Perl syntax, and even for people who are and still hate it, the Perl has 7 characters that, depending on whether you're looking for an expression or whether you're looking for an operator, totally affect the way the following things are tokenized. In particular, something like a / is sometimes the beginning of a regular expression if we're looking for a value, but it's also a divide by if we're looking for an operator. Can you represent that kind of ambiguity with MARPA?
Yes. And out of the box, as like you said in the intro, if you were just to give it sort of a naive grammar of Perl, it would potentially, well, I mean, in this case, it always is unambiguous in the end. So MARPA would just sort of power its way through, and it would know when it gets to a slash, it would say, well, this can't possibly be a term. It has to be an operator. So I'm going to treat it as a division operator. And so it sort of does that work for you.
Now, Perl's probably one of the worst things to parse, which is why everybody always keeps saying, first off, there's too much overloading. Actually, it's not really ambiguity because you can always define what it is, but there's a lot of overloading going on. Is there a subset of Perl parser with MARPA already?
I'm not sure actually. I don't know of one, but that sounds like the kind of thing that Ron Savage may have done, because he has written parsers. Actually, I know he's written one for C in MARPA, as well as JavaScript and SQL.
Cool. And what's your relationship with Jeffrey and with Ron Savage? Are you just all internet buddies, or have you worked together?
Internet buddies is pretty close to it. I got interested in MARPA independently, and I wrote a little bit about it and published it on the internet. And Jeffrey contacted me to talk about it, and we've been talking ever since.
And are you contributing code to the code base?
Not substantially. I've fixed a couple semicolon errors and that kind of thing.
Mm-hmm. And it's mostly in Perl, or I think mostly it's in C, right?
The real guts of it is in C, but there's a lot of it in Perl as well, because mostly people have used it from Perl. In any case, the C library is much lower level.
Yeah, and go ahead. Sorry.
But the C library keeps it nice and fast.
Yeah, is that something that people could write bindings to in other languages, or is there just too much of it in Perl that you even think about doing, say, a Python binding for this?
It's completely possible. I know that Jeffrey wants people to write bindings for other languages, and I've seen somebody recently who is working on a Rust binding for MARPA.
Rust? What's that?
It's one of those new fancy programming languages. I believe Rust is the one that the Mozilla project is backing.
Oh, okay, cool. Can you talk a little bit about I remember seeing a recent article from Jeffrey, or maybe it was from you, or maybe Ron, I can't tell now, about the ambiguous parsing of HTML and figuring out what the next token has to be, and doing, I forget what the technique is called, but actually filling in the right closed tokens or the right open token for HTML.
Right.
Are you familiar with that? Can you talk a little bit about that?
Yes, I am. And MARPA calls that Ruby slippers parsing. I don't quite remember the context that came from. But yeah, HTML is another interestingly tricky language because people have always written really bad HTML. And so if you were strict about it, if you said, every time you don't nest your tags properly or close your tags properly, then you just get an error page in the browser, then most of the internet wouldn't load. And so browser vendors, they didn't want that to happen. So they dealt with errors. And it got to the point where HTML5 says, well, this is the correct grammar, but everything that's wrong is also right. And this is how you deal with anything that's wrong. So it specifically says, if you get to a closing tag and there's other stuff that hasn't been closed, then you should pretend that it's been closed in a particular order. And MARPA has the ability to look at what tags are what rules are expected in any given place. And if what you found isn't one of the things that is expected right now, it gives you the chance to actually give it something else. And in the context of an HTML parser, you could say, give it a close tag for something that hasn't been closed yet until you get to a state where the tag that you actually have is legal, and then you can keep moving with your input.
So if someone was looking to use like MARPA, if they were listening to the show and they thought like, oh, this would be perfect for a project I'm working on, and I assume it comes with a number of supported grammars or supported parsers for formats that already exist today. Is that correct?
There are some. I wouldn't say they're bundled into the project, but on CPAN, I recommend using Meta CPAN. You can find MARPA on CPAN, and you can also find a bunch of parsers that have already been written under the namespace MARPA X : language, and you'll find things there for, as I said, things like JSON and SQL and other interesting things, and hopefully people will contribute more.
Okay. So, I mean, if someone was interested in writing their own parser, how would they go about doing that? And then how would they go about contributing back to the project?
So, I mean, the first place to start is to go on CPAN, look up MARPA, look at the documentation, look at the website. The website that's linked here is sort of the central hub of MARPA resources, and there's a lot of tutorials and things that you can read there to get started. And I think right now, the recommended thing to do would be to upload to CPAN. So if you don't have a pause account, get one. It's easy, and turn your grammar that you've written into a module and upload it there. But if that sounds scary, then come by the IRC channel and ask for help, and I'm sure you'll find somebody willing to help you out.
Just for our audience, what is that IRC channel, and what network is it on?
It is on Freenode, irc.freenode.net, pound MARPA.
Good. Makes sense. So a question from the IRC channel, the Twit IRC channel. Would MARPA be suitable to plug in for someone building a compiler, or is that overkill?
I think it's practical. As I said, Ron Savage has actually written parsers that will parse C or JavaScript to an abstract syntax tree. Obviously, that's only the very beginning of a compiler, but you could go from there and actually build a C compiler on top of MARPA if you were so inclined.
Okay. So is it possible to use MARPA in its current state? Like, say you had a file or some text in a certain format, and you wanted to kind of translate it into a different format, either like spoken language or actual, like, say, like, I don't know, HTML into XML or HTML into JSON or something like that. If you wanted to go from one format to another, is that possible with MARPA today?
Yes. And one thing I do want to point out there is that MARPA definitely, it can take some input and build up an abstract syntax tree in memory. But you can also use it in a completely streaming kind of way where you deal with stuff as it's recognized. So if you have something gigantic, or if you want to translate input on the fly into a different format, it's not like you have to load up the whole thing into memory before you can start working with it.
So we've spoken a bit about what MARPA does really well, like the formats that it's able to kind of parse and everything. Is there anything that it cannot do well? Like what are its current limitations?
I haven't thought about that one, to be honest. I think there's still room to grow as far as expressiveness, and as far as making it easy for people to get started. I still think it's less intimidating than some of the alternatives, but also a little bit less friendly than maybe it could be.
Okay. So how does MARPA compare with say, like, if someone wrote their own parser speed-wise? Like, obviously there's advantages to using it. How would you say that is compared to like YACC or Bison?
It depends on how good you are. If you're very good and your language is one that Bison can handle, and you write a good Bison parser for it, then Bison is probably faster at this point. If you are more intermediate sort of skill level, then I think there's a very good chance that MARPA will produce code that's better than what you would be able to write by hand.
Okay.
So it's somewhere in the middle.
Okay, so like they're pretty comparable at this point.
Yeah.
Okay. So what's the most interesting use case that you've heard of for using MARPA at this point? Either like the most interesting, I guess it's two questions. The most interesting kind of grammar or parser that you've seen, and the biggest kind of amount of data that you've heard about someone using MARPA to kind of process.
Interesting. I'm trying to remember what the use case for this was, but Ron actually had a real life thing where he needed to work with and transform some GraphViz graphs. And GraphViz is a text-based format for expressing the kind of graphs with, like circles and bubbles and lines between them and labels and stuff like that. And he wrote a MARPA grammar for that to be able to parse and transform and produce GraphViz files. As far as volume of data, I don't have any sort of information about that.
Okay. What's the most interesting thing that you've done with MARPA to date?
So something that I actually had started on was that TAP, the Test Anything protocol. And years ago, there was an effort to actually make that into an RFC. Technically, the project isn't dead, but it's pretty much stalled at the moment. But that means that there is a BNF grammar for TAP, and somebody had asked me to write a parser sort of clean room based on the grammar, not based on all of the parsers that exist out there in Perl and other languages. And I had written it years ago in parseRecDescent. And whenever I learn sort of a new parsing technology, it's just become a thing for me. I try to rewrite that spec version of the TAP grammar in whatever I learned. And MARPA was very interesting for me because I came up with a technique for parsing TAP where there was a grammar that would recognize any single line of TAP, whether it's a test result or a plan or a skip or different kinds of things that TAP can have. And the output of that was fed as tokens into a second grammar that actually encompasses the structure of a TAP document. So it's whether you output like the number of tests that you're going to run at the beginning or at the end, and whether you have comments and things like that. And it came out very, very interestingly. It was very efficient. And it also gives the best error messages that I've ever seen, because instead of saying something like, well, I expected a number and I got a pound sign, it will say, I expected your test plan to be here, but I got a comment. Which is very interesting. That sort of MARPA's level of introspectiveness lets you give better error messages than some other things.
That's one of the things I'm always frustrated by sometimes. Sometimes, that sounds bad. That's ambiguous grammar there. I am frequently frustrated by the error messages that come out when something goes wrong. When everything works right, the parser is great. It did what I told it to do. But when something goes wrong, like I remember working with Yak early on, and it was horrible at telling me what it was sort of looking for here. It just said, yeah, bad parse. Well, why? Why is it a bad parse?
Right.
Can you talk a little more about how the error generation interacts with MARPA and why that's so much better in MARPA?
So historically, there've kind of been two different classes of parsers. You have the top down ones that sort of start with a top rule and then drill their way down through the grammar before they even deal with your input. Um, and so they always know where they are in the grammar, which means that when they get something unexpected, they're usually good at producing error messages, but they also tend to be inefficient as well. And then you have the bottom up table driven parsers like Yak that tend to be a lot more efficient at actually doing the job. But the whole grammar at that point has been boiled down into a bunch of binary gunk where it all works out, like the math works out. It knows, but basically all it knows is what character should be next, and it has to do a lot of hard work to try to reconstruct. If it gets something that it doesn't expect, it doesn't really know why. And MARPA uses a completely different algorithm from both of the different algorithm to both of those that has some of the advantages of both.
And actually, can you talk a little bit about that? I mentioned early in the show, I guess. Wow. Okay. Can you talk about the work Jeffrey did to convert the early algorithm into the early versions? Another again overloading of MARPA, and what he's done since then. And he's incorporated stuff from, as I'm looking on the paper here, from JupLeo and something else too, or the ACOC Horspool stuff. Do you know much about that, or is that something I should be asking Jeffrey?
A large portion of it is over my head, unfortunately. I know the executive version of it, which is that the early algorithm has been around for a long time, and it was basically dismissed as being too inefficient in the 70s when it needed a substantial amount of RAM and computers had kilobytes of RAM. And so it was like, well, that's a very nice algorithm, but nobody's going to use it. And over time, especially with that Leo paper, there were improvements made to the MARPA algorithm, to its worst case complexity, to the amount of memory that it needs, and at the same time, computers have gotten more and more powerful to the point where an early based parser and MARPA is very practical now, but it's if anybody knows about it at all, they sort of consider it old news.
Yeah, okay. And so what I'm seeing actually in this document that Jeffrey published a while back, I think last year, he says he took the early algorithm and made use the improvements that Leo had come up with. But it said Leo's mathematical approach did not address some nagging practical issues, handling of nullable rules and symbols. And 10 years later, ACOC and Horspool figured that out, but they didn't know about Leo's work, which I think was really fascinating, that two people started with the early algorithm and solved two different problems with it. And I believe Jeffrey's work is the first time those were brought back together. Do you know of any other languages? Right. Do you know of any other languages that something like this is implemented in yet?
I do not.
Yeah, because I think that's part of why I wanted to do this show. I want to get people inspired that aren't working in Perl to take some of Jeffrey's work, and he's published papers on this already, and to actually build real, maybe entirely C-based or some other language-based application, so that this particular app, I don't have to be working. As much as I like working in Perl, not everybody's using Perl. So I'd like to get this out a little bit more in the practical nature of things. One of the things I found fascinating about the early algorithm is the way it steps forward, having all possible ambiguous parsings sort of in memory at the same time. Can you talk a little bit about that and why that makes it interesting?
Sure. It comes back to what makes it so accessible, because it means that you can be a little bit unsure about what you're looking at. You can say, well, it might be this or it might be that. and the algorithm will tentatively go forward with both. And if later on it finds something that sort of invalidates your assumption, it says, oh, well, I thought maybe I was parsing a regex, but I found this thing that can't possibly be valid in a regex. In another kind of parser, that might cause an error, or it might cause a backtrack where it's going to go back and say, all right, well, let me try it as something else. But the early algorithm has both of those concepts in memory at the same time in an efficient way, both possible guesses about what you might be looking at. So if one of them turns out to be wrong, it just gets pruned. It's not going to think about that one anymore, and it's going to go ahead with the ones that do work. When you get to the end of your input, if you have, as long as one of those possibilities worked out, then it will give you the parse based on what is actually consistent with your grammar. If more than one of them worked out, then it has the ability to give you multiple parse results, and it will tell you, well, this was ambiguous. Your grammar doesn't actually allows more than one possibility for this input, but if you like, I'll give you all of them.
For those that are used to using other types of grammar generators like YAC and things like that, can I do the same thing that I do in YAC when I have levels of precedence, like multiplications more tightly bound than addition, or do I need to do it by having named separate rules that call each other, like in some more limited parser generators?
You can do precedence very easily. If you have a list of alternatives for a rule, if you separate them with a single bar, then those alternatives are at equal precedence. And if you separate with 2 bars, then it will just lower the precedence a level for you. So you can do precedence parsing very easily.
Wow. Okay. Well, that makes it really simple. I don't have to put like in YAC, you do press, you say higher level, lower level precedence. It's all sort of magical. That sounds really cool. How large is the actual MARPA development community? It's obviously Jeffrey and maybe some other people. Can you talk about that?
There are definitely other people working on it. Jeffrey basically runs the project and takes all of the contributions, but there are other people who contribute to the code. I'm not going to try to list names because I'm sure I'm going to forget some of them.
Okay, they can always go to the page for it, to the CPAN page for it, to figure out who's actually contributing to it. Is this being driven by a business interest? I mean, is Jeffrey working on this just in his nights and weekends, or is there some sort of business interest behind making MARPA better and cooler?
As far as I know, it's a labor of love for Jeffrey.
Okay, well, that's cool then. And I'm thinking more about how I'm interacting with it. The tokenization is done sort of in parallel with the parsing. Is that all in the same file, or am I doing like a separate Lex and YAC kind of deal, or whatever it's called, the equivalent of GPL stuff, Bison and I forget the name of the thing. It's parallel. Flex, there it is, right? So is it like Flex and Bison, or do I need to, or is it all one file, or can I have a completely separate grammar for the lexing?
You can separate it out if you want. If you want to have your own sort of lexer or tokenizer, then you can feed the input of that into MARPA. But the easiest way is you can actually you can specify your tokens right in the MARPA grammar, and MARPA will build a lexer for you. So all you have to do is write your grammar with your rules and your tokens, and give it input somehow, and it will do everything for you.
Now, one of the cool things about Perl 6, I don't know how familiar you are with Perl 6, one of the cool things is this notion of grammar as a fundamental language construct. Do you think that that Perl 6's grammars, if you're familiar with that, could have been influenced by MARPA, or do you think MARPA's got a better setup than Perl 6 grammars, or I don't know, can you compare the two?
There's been a little bit of discussion about that recently. I know that Jeffrey and Larry Wall have actually chatted about it a little bit. Initially, I think there was very little back and forth. Perl 6 grammars have sort of gone in their own direction. Perl 6 grammars uses a recursive descent technique, so not anything like the MARPA algorithm. But there has been some discussion and some sort of in the Perl spirit, let's see what good ideas Perl 6 can steal from other places.
Sure. And is there an equivalent in MARPA of subclassing a grammar? Because I know that's one of the really cool features of Perl 6 is that Perl 6's grammar is written in Perl 6, and you can create essentially a custom version of Perl 6 subclassing the grammar while it's being parsed. Does MARPA provide a similar facility for that?
Probably to some degree, because you can definitely take a grammar and add rules to it, and you can definitely take a grammar and for example, subclass the class that provides the semantics for it. It's probably not done in quite as straightforward a way as it is with Perl 6. I don't think it's a primary use case, so to speak.
Okay, and one other question about that. I know that parsing C is a little tricky because of type defs, that type defs sort of nuance what's coming after it. Is that really simple to do in MARPA? Can I, once I recognize that this is a type def, then that has a different sort of parsing or lexical state, essentially, when I see that word the next time.
So it is possible to deal with that, and what you would end up doing is you would have that rule that says, at this point a valid type name appears, and the grammar doesn't know in advance what actually is a type that exists or doesn't. But you can pause the grammar at any given point and pass to the code that controls it. And so you can pause at the point where a type name comes up and say, is this a type name that I've seen before? If so, then I'm going to put in a token that says that this is a type name. And if I'm not, or if it's not a type name that I recognize, then I'm not going to, and that particular rule isn't going to work out. So that's one of the ways that MARPA lets you sort of dynamically, because you can't actually, like rec descent, for instance, would actually let you modify the grammar at runtime to do that sort of thing. But because MARPA is a table parser, it can't actually modify its grammar on the fly, but it does have some tricks up its sleeve to let you do that kind of dynamic thing.
Awesome. And so is there a minimum size project that I would have to have before I would first reach for MARPA?
I would say not necessarily. With a Perl project right now, the only concern is whether you want to require your users to have a C compiler to be able to install your module, because there was at one point a pure Perl version of MARPA, but that is years and years old and doesn't, not relevant anymore. But it's very low overhead. I have a module that does a very small thing with MARPA and does it well.
And if you're good at regular expressions, you can parse almost anything. I mean, that's. I wrote a JSON parser in pure regular expressions, so that was kind of crazy. But I suppose spelling out JSON as MARPA would be pretty trivial, because I basically built a recursive descent parser using Perl regular expressions, and you would do roughly the same thing with MARPA, right?
Yeah, I think the grammar would come pretty close to fitting on your screen.
Wow, yeah, and the regex, if you want to see it, if you Google for pure Perl, Perl regex JSON parser, I think I'm like the first hit. It was both incredibly scary but incredibly fun to write. So that was really, really pretty cool. Well, we're almost out of time, and this has been a really geeky show, but I'm wondering, are you looking in the MARPA community for new contributions? It sounds like you want a Python parser, or a Python binding to the C stuff. Is there any other sort of thing people are looking for?
I haven't heard of specific wants. I just think that people should get interested, and they should come and do what they like and contribute things that meet their needs, and come on and get interested with us.
And I should ask the standard questions. Like, I presume this is under the standard Perl license, right?
I believe it is.
Yeah, the combination of artistic and GPL or whatever artistic 2, I think it is now, if it's
right.
Still in the same area. So yeah, this is like I said, this has been an exciting thing to watch develop, and I'm really hoping other people will adopt this for their particular languages and make everything better in the world. And thanks to Jeffrey's work for bringing that all together. Any last things you want to tell our audience before we cut you loose here?
Let me look at my notes real quick.
Okay. Yeah. That's always the most difficult question I ask every guest, which is because they're trying to remember what they haven't said yet, which is a real tough thing to do.
Right. Just to let you know, on the license, it's GPL2, which is not the most common thing for a Perl project, but not the least common either.
That's interesting. So if I embedded this in my application, it would become GPL. Has anybody embedded this in anything you know of?
Let's see. I know the person who was working on the Rust bindings. I know somebody who has an interest in putting MARPA through ASM.js so that they can actually use a MARPA parser in JavaScript in the browser.
Ooh. I'm not. I never did the traditional CS route. I'm a street trained programmer, so all this stuff, like just being able to use parse-rec descent was sort of an amazing jump forward for me, because I didn't study the Gang of Four book or the Dragon book or so in school, because I didn't go to school for that stuff. So I always find it great when somebody else can do all the hard work, and then I can just use whatever they've developed. So. That sounds like someplace that now I don't know where I was going to go with the answer to that. So anything else, or are we done?
I want to correct myself, because I just told you a lie, and it's potentially a bad lie. It's not GPL, it's LGPL, so you don't have to worry about embedding.
Oh, even better, even better. Thank you, Jeffrey Kegler, for doing that for us. That's great. Well, Andrew, it's been a pleasure having you on, and I'd say I think probably a third of my audience has their eyes now totally glazed over, or they tuned out halfway through. But for the programmers and us, for the people who have to get real work done and actually write code that other people get to use, things like MARPA are really, really helpful. So I'm glad we had a chance to chat with you today about Jeffrey Kegler and MARPA and parsing and ambiguous things and multiple meanings for the word early.
Thank you.
Thanks, Andrew. That was Andrew Rodland representing the MARPA project. Gareth, I suspect your eyes were mostly glazed over, but what did you think?
No, it's very, very interesting. I mean, it's definitely, it sounds like a really interesting project, and the fact that they want other languages to to adopt what they've done and make the ability to kind of use their work to make parsing and make grammar processing a lot easier across the board. So that would be really exciting.
And this is one of those sort of, not exciting tasks. In fact, every time you end up at the point where you've got to parse something with a regular expression or with Yak or some other kinds of tools, it's always like, ugh, that's the part that I kind of hate. That's not the cool part of the algorithm. That's just getting the data in somehow, But having tools like MARPA and other things around really help for being able to solve those problems by leveraging from the people's work. It's like we don't have to write, equation solvers because it's already there in libraries. We don't have to write the thing that say talks HTTP over the wire because people have already written those libraries. And MARPA is just one more tool in that range of things, except it's a powerful leveraging tool. And like I said, that's why I wanted to get them on the show here, because I want more people to know about MARPA. I'm still looking for my first big project to do with MARPA. I've been studying the man pages and stuff and writing little toy things, but nothing that's actually has something I could speak about. But that's sort of why I wanted to bring them on. So, speaking of upcoming guests, I have been working furiously behind the scenes to flesh out the rest of Q1. I think I sent like 18 emails yesterday and about 15 2 weeks ago. On the short list, we have already, we do have one more booking. It's coming up February 4th. We've got the SOGO project, or I guess, S capital S-O-G little O. It's a groupware server with a focus on scalability and open standards. So they're coming on for sure. On the extremely short list, but not dates scheduled for them yet, we have NTP, the network time protocol, the thing that keeps all our computers synchronized, our watches and our phones and all that stuff. The NTP is software. One of the guys on the project, it's all open source software, of course, that does that, is going to come on and talk about what the impact of NTP is. So one of more infrastructure kind of shows, which is kind of cool. And we're going to get Docker back. We absolutely are going to get Docker back. I just got an email a couple days ago from the coordinator there, and she says, yes, we're definitely going to have Docker on. We're just looking for the right date in the upcoming list. A lot more on the short list. If you go to twit.tv/floss, you can pick up the upcoming guest list. You can see all the movement I've been moving around. If they move closer and closer to the top of the list, it means I've sent out email to them recently, so you can kind of see them as they move around that I've been emailing all these guys. But if there's a project that you think is interesting and isn't on that list, please email the project leader and have them email me, merlin@stonehenge.com. And my address is on the twit.tv/floss page, which if you're watching the video is linked up there, and also on the, I keep saying it over and over again. There we go. You can follow us on Google Plus at Floss Weekly, and I do announce when I get new guests, and I also try to do a reminder just before the show comes out. And we're also Floss Weekly on Twitter if you want to just follow it that way. We do have a live chat. We took a couple questions from the chat here. This at live.twit.tv when we're taping, which is usually 8:30 a.m. Pacific times on Wednesdays. It's the earliest show on the Twit network. Yes. You can follow me at Merlin, M-E-R-O-Y-N, on Twitter. I'm also Randall L. Schwartz on Google Plus. I'm going to be in Cuba next week, so I won't be hosting the show, but hopefully we'll have a show lined up for next week. Excuse me. And I'll be at Scale in February. We'll talk about that in a second. And I'll also be in New York City in late March. So watch my feeds to figure out where I'm specifically going to be. Probably have meetups at all of those areas. Well, maybe not a meetup in Cuba. I don't know how easy that's going to be. But speaking of Scale, what do you want to plug there, Gareth? I think there's something you want to plug.
So yeah, Scale is fast approaching. So we're just over a month away. It'll be happening in Los Angeles, California, at the Hilton LAX again, February 19th, 20th, 21st, and 22nd. So we've added an extra day this year. So we'll be a Thursday, Friday, Saturday, Sunday show, as opposed to a Friday, Saturday, Sunday show. So, excuse me, we'll have another full day, Thursday of content, so specialty sessions. And we've also added our expo floor to Friday. So anyone coming out for Friday, for the sessions that happen on Friday, they'll be able to wander the expo floors on those days as well.
Yeah, and I highly recommend it. It's a really great show. In fact, it is the largest show named Scale in the world.
Yes, it is.
But,
the largest and only show.
Because I was trying to compare it to other Linux expos. It's probably one of the largest of those too, right?
It's of all the Linux shows in North America, I would say it was the largest at this point. I think the closest in size, maybe a little bigger than us, is OSCON. And I think they trump us with the number of sessions. I think they're up to 60 concurrent tracks at the moment.
It's something like that. It's really insane, and it's a heck of a lot more expensive. So, and that's actually another thing I want to bring up. You have a special deal for us Floss Weekly listeners, don't you?
I do. So normally our admission price for the full show is $60, but if listeners use the code FLOSS, they will get a 50% discount. So it'll be $30 instead of $60.
A bargain at either price compared to like the thousands of dollars people pay for OSCON. So very, very cool. Very good. And Gareth, thank you for joining me today. And we'll see you all again next week on Floss Weekly.